We are going to solve a problem with Laplace. So you should have probably already solved this problem with those initial conditions, doing a characteristic equation, getting r equals 2 and 4, taking a derivative, doing a matrix, and getting this thing right here. So I'm going to solve the same problem with Laplace right here. What I do, I start with the equation and the initial conditions. And I have these formulas that we've worked out. This is the Laplace transform of x double prime. So x double prime is going to Laplace to capital X minus s times x of 0 minus x prime of 0. What's that going to give me? When I Laplace this right here in red, this thing's Laplace is right here in red. I get s times x minus, what do I get? S times x of 0. Well, x of 0 is 3, so I get minus 3s. Notice x prime of 0 is negative 2, so I get minus x prime of 0. So I get double negative, I get plus 2. Then I get minus 6, that's this, times the Laplace of x prime. The Laplace of x prime is s times big S minus x of 0. So I get s times big S minus this 3. And then I get plus 8 times what's the Laplace of x? Well, I just write a big X. And then it's equal to 0. And then I'm done with all this stuff. Now watch, it's kind of magical. So what am I going to do? I am going to factor all of the x terms over on one, leave them all on one side and move everything else over to the other. So first thing I need to do, though, is to distribute this negative 6. This gives me this line right here, negative 6x, and then I get a double negative there. That's kind of the biggest error spot right there, or if that shows up sometimes here. I guess no, it's probably just really right here. Plus 8x. So everything is exactly the same as here. Now, x term, x term, x term. Those are all going to be left on the left side and factored out. 3s moves over to the right. 2 and 18 get added together, then move to the right, become a negative 20. From there, I'm going to divide out by this right here, and I'm going to get 3s minus 20 over s squared minus 6x plus 8. From there, I can factor the bottom, and then this is where your skills from before come in. You should know how to do cover-up. You should really know how to do cover-up. It's like amazing. But what we do is I use cover-up, and I split this thing out into two different terms. Something over s minus 4 plus something else over s minus 2. And I get that I get a negative 4 and a 7. So you should be pretty good with those. Now, okay, so we are almost here. From here, all we got to do is I'm going to take this 4 and just move it out front. I get x equals negative 4 times 1 over s minus 4. And I get the other one as plus 7, just move the 7 out front, times 1 over s minus 2. And lastly, this next step is something that you haven't seen yet, but I think it should make some sense. So, do you remember that the Laplace of e to the at was 1 over s minus a? Well, I can undo these things. That means that if I have 1 over s minus a, it will inverse Laplace to e to the at. Notice this is 1 over s minus 4. What do I get when I inverse Laplace that? I get e to the 4t, because the s minus a is an s minus 4, so the e to the at is e to the 4t. And then the 4 comes along for the ride, like many of the things that we've been doing. And this one, you guessed it, it goes to e to the 2t with a 7. And now, let me zoom out so that you can see that green answer right here matches what we got up here when we did it in the old school way. So this may seem long right now, but as you gain efficiency with this, these Laplace transform problems, they can be faster than doing it in the old way. And I've said this many times to you where it's good to have more than one way to do things. Sometimes, and we'll get to it, the Laplace transform is way more useful than doing it in the old school way. And notice This was all algebra. So anyway, Laplace transform, super useful. See you soon. Bye.